Hello, everyone. Welcome to the next session of our Devon and Beyond Did You Know series. In this webinar series, we focus on new features and enhancements of Oracle Cloud Infrastructure and discuss how these solutions empower businesses to achieve great efficiency, security, and scalability. Whether you are a seasoned OCI user or just starting your cloud journey, you're in the right place to explore what's new. My name is Renu Bhatt, Program Lead for the Customer Enablement team here at Oracle. And joining us today for this webinar are Ivan Slater, Senior Principal Product Manager, and Anand Prasad, Master Principal Cloud Architect. Our topic today is faster, leaner applications with Oracle GraalVM. And I would like to start the session with a question for Ivan. So Ivan, what exactly is Graal?
Graal actually means Graal in Old French. And if you look carefully through the slides in the presentation, you may see some rabbits. So there's a bit of a Monty Python theme going on there. And it's a technology that is used by our customers and also within Oracle itself to make applications more efficient and reduce costs, particularly in the cloud.
Awesome. Anand?
Thank you, Renu. Good morning, everyone. Now, I saw the poll, many of you are concerned about the cost, right? That's very good to know. But I wanted to ask Evan a question about, what is this Holy Grail our customers are looking for today, right? We talked about lean applications in the beginning of the title. Evan, do you want to take a shot at what is the Holy Grail our customers are looking today?
I think the Holy Grail that they're really shooting for is something that I would call digital efficiency. So if you think about it, every company today is a digital company. I live in a little market town in England. The laundry service in the town has their own app. The fish and chip shop takes online orders. So even those kinds of businesses are operating as digital companies. Generally speaking, to be a digital company means that you need to differentiate yourself from the competition, and you need to personalize your offer to the customer. And the way that you are generally going to do that is with software. And you're going to need to do this with agility, because you need to be able to respond to the changing market. And you need to be able to do this at scale, because potentially you have, maybe everybody on the internet as a customer. And that means that you're going to use the cloud. But while I think a lot of organizations have understood that, I think the part that they're struggling with is the efficiency. So if you look at a couple of those numbers that I've put up there, Forrester, they did some research last year, and they believe that over 30% of the spend that companies are making in cloud is wasted. And the vast majority of organizations, over 70%, are struggling to drive customer value through the cloud. So for the majority of organizations, they're not delivering the value they're looking for.
Perfect. Now, I saw the numbers you are showcasing. Let's talk about what is beyond all this, proper lack of resources utilization, or I call it waste. What is beyond all this waste, which you can comment on a little bit?
So I think that's a really important question. And what I think it really comes down to is a couple of things. And the first is that we've got new infrastructure, the cloud, but people are still thinking in the way that they used to think on premises. So people are doing the equivalent in cloud of buying the biggest box I can, and then I'll run my application on that. And so you see that over 65% of containers are using less than half of the allocated CPU and memory for that container. And the reason for that, I believe, goes back to something earlier, which is that people are creating applications that they are aware are not particularly efficient, that don't use CPU and memory particularly well, and therefore there's a kind of safety blanket attitude, which is I'm going to just, as we would on premises, I'm going to throw a big box at it. In the cloud, I'm going to throw a big container at it and hope that way my application will stay up and the lights will stay on. But it is a very wasteful way of doing things.
Thank you. Now, you might have this leads to a very good question about how is Oracle trying to solve this problem and help customers, right? You probably have thought about sizing issue, like how to reduce this waste and everything. What is Oracle take on this?
Okay, so I work for Oracle Labs, which is part of the research and development organization of Oracle. And we believe that the way that we need to tackle this waste is to address application efficiency. And so we've created a technology called GraalVM. So if you think about the applications that a lot of people are creating today, they use too much memory, they use too much CPU, and memory in particular is very expensive. They also start too slowly, which increases latency. And then if you have, for example, an SLA around latency, and you start to fail to meet it, one of the things that your platform may do is to start more instances of your application to compensate for the poor latency. And that's particularly going to cause you a problem around serverless applications. And that in turn is also another issue, because customers today are wanting to use serverless because they want to avoid having to run applications when they're not needed. So we have developed a technology called GraalVM to help address that, certainly for applications in the Java space. So how GraalVM does this? GraalVM is an advanced JDK. You can just run your Java programs on GraalVM if you want to, just use it as a drop-in replacement for the standard JDK. But it also has the capacity to do ahead-of-time compilation to machine code. So GraalVM takes your Java application bytecode. So it's taking your application, it's taking the libraries, it's taking the JDK, and it compiles that into machine code that's going to start faster, has higher throughput, uses less CPU, and uses less memory. So at the compilation stage, that's the part you see in the center of the slide here, GraalVM will run this iterative process. We call this native image compilation. And it will go through the code. It will run any initializations that it finds. It will put those onto a snapshot of the heap so that when your application is run, all of those things are already there. So the startup time is quicker. And also we're going to eliminate any code that we don't find is used. So that could be if a method isn't used, if a field isn't used, if a whole class isn't used, they won't make it into the native executable. And then when we've got to the optimum solution, so we keep iterating and we can't get to a better solution, then we write out our native executable, and you can then run that. And you can also package that into a container, and that will be a smaller, lighter weight container than you would have used for the Java application. Another benefit of that elimination of unused code is that the less code you have, the smaller your attack surface will be. And because we are now putting an executable into the container, the container itself needs less stuff in it. It doesn't need to have, if you like, the life support system for the JDK and the Java application. And that means the container itself has fewer vulnerabilities. Just to look at the reduction in size that we get, this slide is looking at image sizes, container image sizes for an application that just starts the simple web server that's included in the JDK. So where the bars are in blue, that's Java. Where they're in orange, that's native image. And on the left-hand side, we take a Debian Slim image, we put the JDK in there, we put the Java application in there, and that's all going to come in at just over 400 meg. If we then look at a distroless container, so that's a slimmer container image with the JDK and the application, that comes down to around about 200 meg. If we then stop using the whole JDK, but we use JLink and JDEPs to get the minimum Java runtime environment that application requires, we come down to 127 meg. Now here's where the magic happens. So the next bar that you see, that's about 50 meg. We've kept the container image the same, but now we've compiled the Java application to a native image, and now we're down to about 50 meg. We can then make the image skinnier because we no longer need the parts for Java. We just take a distroless base image, and then finally what we can do is we can link the image statically, so we wind up with a distroless container with a static native executable in it, and we're down to 18 meg. So that's a really significant shrinkage in the size of the container and the amount of things that are in the container. So that's looking at the container size. Now let's look at what the effect is on application performance. So if we think about the Spring Pet Clinic application that many people will be familiar with, we can run this as a normal Java application. We can run it as a native image. If we run it as the native image, what we see is that we use 38% less memory. We see 28% lower latency. We see 8% higher peak throughput and 49% higher throughput per memory. So for every gigabyte of memory you're using, you're getting nearly 50% greater throughput. And the application will start up 34 times faster. Now, your application, is probably not Spring Pet Clinic, but I think it gives you an idea of the kind of improvements in performance that we're talking about and the kind of cost savings that you can make.
Well, you talked about Spring. What are the other frameworks Oracle is supporting? I'm pretty sure you're supporting many other frameworks. Can you comment on that, Evan?
Yeah, so Spring and Micronaut and Helidon and Quarkus all have support for native image out of the box. So for example, if you're using Spring, you go to the Spring initializer, or if you're using Micronaut, you go to the Micronaut launcher, and you specify that you want support for native image included in your project. Obviously, all of these frameworks have a kind of launcher, all of them have a command line as well, but you say that you want to be able to compile to a native image. And then it's simply a case of when you do the build, you specify whatever extra flags that framework requires, and it will compile to a native image for you. And this makes getting started with native image much, much easier. And we are getting a lot of traction in the industry. In the last couple of months, I've been to KubeCon EU, I've been to Devox, I was at a conference in Lithuania last week, and I'm constantly being asked about GraalVM. If you look at YouTube, you'll see that the Spring community, people like Josh Long, people like Seb Deleuze, they're very excited about GraalVM. So this is an area where Oracle is definitely leading. GraalVM is an open source project. We welcome contributions from the community, but it is led by and it's from Oracle Labs. There's a community edition and there are downstream builds, the open source code, but you can get the Oracle GraalVM, which is the Oracle supported version, and that has some additional optimizations and higher performance that you don't see in the community edition. And this is where the Java community is really going towards compiling Java code to native images. Somebody said to me at KubeCon EU, he said, you guys are saving me from Go. And that's really one of the things to think about. The alternative, if you want to make your applications more performant, is to switch to, say, a different language. But that means that you're having to retrain your developers, or you're going to have to go out and hire new ones, all the while you're trying to run your business and trying to be agile and efficient.
Thank you, Evan. But I think you showed us a lot of this data points as well as compelling features. I'm very curious to see something which you can show to us, right? As there is a great saying, seeing is believing. Can you showcase us from your Oracle side, how does our GraalVM helps us to save cost as well as resources?
Let me have a go. So what I'm going to do here is I'm going to run a demonstration, and what's going to happen here is I'm going to start up container containing Spring Pet Clinic. I'm going to run it first using conventional Java. The containers have all been memory constrained to the same size. And to make this fairer for Spring, we're going to run it twice so that you'll have Spring when it's warm, and you'll also have it, obviously, the first run, it's going to be cold. Within the container, we're using a tool called Work, WRK, which is going to basically load the application. So we're going to create pets, we're going to create vets, we're going to create appointments for the pets, and it's going to run through that, as I say, twice for Spring in the Java mode and twice for the same application compiled to a native image. And then it'll show us some graphs at the end to demonstrate the CPU and memory usage that we're seeing in this application and the latency. Now, this is going to take about 3 minutes. What I can do in the meantime is I can also show you the difference in startup time. So this is I've just gone to the Spring Initializer. I've just created an application that just has the native image support in, so it's not really doing anything clever. And we're just going to run that. And then what we'll see is the startup time. So that's started up in 1.76 seconds. Yeah, let's just stop that. I've also got the same application compiled to a native image. And if I run that, you can see that started up in less than 1/10 of a second. So we are talking, orders of magnitude difference in startup time. And if you were running an application which was, say, based around serverless functions, or you needed to be able to scale out, scale back quickly, so start up new applications, stop them, restart them on demand, this is potentially going to make a significant difference to the performance of your application and to the number of instances that you're going to wind up running. Let's see how we're getting on with this. We just need to wait for a couple of minutes. So start it. Okay, this is the data that we've generated. Can you see that okay?
Yes, I can see it, Evan.
Okay, so what we have here, I'll look at the first, we've got memory and CPU utilization. So this is running traditional Java, just-in-time compiler, and this is running native image, which is the ahead-of-time compilation. And there's a couple of things that we can see immediately, that the red area is much larger on this side. That represents the CPU usage. It's also much spikier. So this is largely caused by Java garbage collection. If you look on the other side, you'll see that the CPU usage is less, and it's also less spiky. The blue line shows us the memory usage. So for Spring running as a Java application, we're looking at nearly 600 meg of memory that it's using. If we look on the other side, we see we're probably using just under 300 meg. So it's about half the amount of memory that we're using. And the CPU usage is, again, that will be half or less. If we look at requests per second, now you can see this is going to be the worst case. So this is JIT compiler, it's cold. Then the second run, the JIT compiler does best, and it will get, over time, it can get better. But what you will see is that the native image optimized cold, getting more requests per second through, and then native image optimized warm is doing significantly better than the C2 cold. You get slightly different results on different runs. What you typically see over time is that in most cases, optimized warm will be outperforming C2 warm. If we look at the latency, you'll see this is the 99th percentile latency. You'll see C2 latency is significantly worse than the C2 warm. You'll see that native optimized considerably better than C2. Sorry, native optimized cold is considerably better than C2 cold. And that when we look at warm, again, the native image is doing better than the traditional Java in terms of that latency. If you are looking at, what's our minimum latency, again, you see native image doing better than the JIT compilation. And if we look at the maximum latency, again, that's much higher for C2 cold, and we get the best results either with warm or the native image. And the mean latency, those are about equal for native cold. If we run this application, if we run this a few hundred times, then you'll see that what would happen, the trend is that the native optimized warm would, over time, look better. So in summary, what native image, what GraalVM allows us to do is to do more with less. Most organizations today are struggling to drive value with cloud. And the real reason for that is inefficient applications. What GraalVM provides is a way to deliver faster, leaner, more efficient Java applications. You're able to leverage the existing skills that you have, so you don't have to go out and learn new languages. You're then able to deliver value in cloud because your memory footprint is going to be smaller, your CPU footprint is going to be smaller. You're going to improve security because you'll be able to deploy in minimalist hardened containers, and you will have less code actually in the application, so you will wind up with a reduced attack surface. Looking to the future, this is something that was mentioned at Cloud World last year, and watch this space over the next few months, but we are going to start releasing more Graal-based OCI services. Graal is being adopted internally within OCI, and the first place we're going to look is going to be at the functions service, so that we can make that even better in terms of its cold start, getting your applications up and running quicker.
Thank you, Evan. Can you share any resources which will help our audience so that I think they can take a look at it and then follow up, and then if they have need more information on the topic which we shared, that will be very useful to them?
Sure, certainly. So there's our main site, which is graalvm.org. And if you go there, you'll see a whole collection of guides, different examples you can work through, depending on whether you want to learn about, how to build a particular application, put it into a native image if you're thinking about deploying to containers. There's also the Luna Labs platform. So if you go to luna.oracle.com, if you've got an Oracle ID, you can log in with that there. If not, you can set one up for free. Search for GraalVM, and what that gives you is an environment that runs in the browser, and you can work through labs doing various things with GraalVM, building applications and deploying them. And we also have some labs on the Live Labs platform, which people on the call might also be familiar with.
Thank you, Evan. I appreciate it. It was a very interesting conversation.
Thank you, Ivan. Thanks, Anand. I know it was a short presentation. Like, these sessions are designed only for 30 minutes. If you have questions later on for us, please feel free to email us at personal-trainers_us@oracle.com. I would like to thank again for all of you for joining the session. I hope you all learned something new today. Our next webinar is titled Run Your Oracle Databases on Steroids within Azure. This will be on Monday, July 22nd. And there you will learn about how you can leverage Oracle Database at Azure to consume Oracle Database services from directly within the Azure cloud with the lowest possible latency. So if you're interested, please go ahead and register for this. And you can go to your Day 1 and Beyond page, register there, and while you're there, go look for other sessions also. I recommend that you bookmark the Day 1 and Beyond page so that you can be notified about the latest sessions that we are adding on training topics. Thank you again for joining us. Thanks again, Anand and Ivan. Have a great day, everyone. See you next time.